Okay, what we're going to do with your pencils, what we're going to do with the color pencils is graph two other functions on the same graph, and we're trying to predict and or discover what happens when we attach numbers to the x squared. Okay? So, first, actually I didn't do the domain and range, so let's cover that first. What is the domain? Domain means horizontal spread. So right here where it says what is the domain, would you put d sub x, please? I put a little x. You can use those if you want. I use a little x to remind myself I'm looking at the x-axis. Domain is horizontal spread. When we write domain and range, we're always going from smallest to largest. So, don't do the shading on yours, because I'm going to be erasing it. But how far to the left does this graph go? Actually, no, it continues. It goes forever. Because it goes out forever. So on the left side, what number is out there on the far left? Negative infinity. And how far to the right does this go? Because we're following the x-axis. It goes to positive infinity. Will we ever actually reach the infinities? No, pretty sure we'll die before we find the number infinity. Because we're never going to make it to infinity, right? So when you don't actually have a physical number there, you use parentheses around it. Negative infinity, comma infinity. Notice the smaller guys on the left, negative is smaller, positive is larger. So when we write these, it should always be smallest to largest. The range, right below, then you put r sub y. I put a y so I remember I'm looking at the y-axis. The y-axis runs vertically, correct? The y-axis goes up and down. And so we want largest to smallest on the height. So again, don't do the shading. I'm going to erase it. How low does this graph go? What's the lowest y value? 0. And then how high? What's the highest y value? Infinity, because it goes up, and beyond, right? Infinity and beyond, like Buzz Lightyear. Okay, now, is there actually a physical point at 0? Yeah, there is. So we use a bracket if we have a point there. But again, infinity, we will never reach. Uh-oh, I think I can delete this, hopefully. Take off my shading. Delete. Okay, that will work. So a bracket if you have a point there. Okay. On part B, we have our parent function, f of x equals x squared, but after the square, there's a plus 2. We're going to try to figure out what is that plus 2 due to the graph. So let's get some points using our table of values on the side, and then we're going to graph that function on the same graph as we did up top where we have the parent function. So, showing your work. Using our brains, not the calculator. Wherever there's an x, we put parentheses, because we're going to plug into it. So, parentheses squared plus 2. This was x squared plus 2. And we're going to insert our first x value. Negative 2. Okay, so, please excuse my dear Aunt Sally. Mateo, what do we have with order of operations that we need to do first? Following PEMDAS. Please excuse my dear Aunt Sally. There's nothing to distribute. That's not even an option, actually. Parentheses, exponents, multiplication, division, addition, subtraction. What do we have? What? Yes, there is addition, but that's not the first one on our list. Are there parentheses, Mateo? Okay, is there anything inside the parentheses to do? No, there's only negative 2. I don't see anything inside to do. So we move to the next one. What comes after parentheses? What is it, Mateo? Exponents. Is there an exponent? So we need to do the exponent. That means negative 2 squared. Mateo, what is negative 2 squared? Yes, you do. Negative 2 times negative 2. There you go. So we get 4 plus 2, which now we can add, and it is 6. We do it again. Parentheses, but this time we type in -1 squared plus 2. We have to do that exponent first. Yeah? Now let's do it step by step first. First square, what's -1 squared? Plus 2 would be, excellent. Okay, then we do the next one, 0 squared. Well, that's nice. 0 squared is just 0, and then we add the 2, and so we get 2. I don't see a repeat yet. Once I see a repeat, then I know what my vertex is, and I don't have to show work anymore because I can just use the symmetry. So let's do the next one. 1 squared plus 2. Gavin, what is 1 squared? Means 1 times 1. Good. Plus 2, Gavin, would be 3. Oh, do we have a repeat? Yes, there's a repeat because I have a 3 there and a 3 there. So in between them, what's that guy called? Vertex. Look, it asks for a vertex, so I'm going to put parentheses 0, comma 2. If ordered pair has parentheses, you put your x value, comma your y value. And then I can just use symmetry, and I know that last guy has to be 6. So, pick a colored pencil of your choice. If you would take that colored pencil and lightly shade the top of this, so you know this guy that we graphed, mine's going to be purple, yours is going to be whatever color you're using. Lightly shade the top to color code your graph. And then we're going to take all 5 of these points and graph them on the same graph up above. So I think I can see both at the same time. So I'm going to find -2, 6 in that color. -2, 6, I'm going to plot that. -1, 3. 0, 2. 1, 3. And using symmetry, 2, 6. Okay, then graph your U parabola through it. What has happened? We added that plus 2 on the end. What happened to the graph? There's a hand. Who notices what happens? We had plus 2 on the end. What's different between the black one and the purple one? Yeah? Okay? Steps in. Put your head up, please, Maddie. What happened, guys? Here's the black one. Then we added a plus 2, and so now the purple one's there. What happened? Jeff? The y-intercept changed? Where did it go? It went up. How many spots up did it go? 2. Interesting. If it says plus 2, we go up 2. So, it's called a vertical shift, up 2. Let's do this guy. X squared minus 3. Instead of the plus 2, there's a minus 3. Okay. Sometimes when people are like that, there's a phone right there, so I was just checking. Okay, no. You're okay. So, the minus 3, will you turn to your neighbor and tell them your prediction of what will happen to the graph if there's a minus 3? The plus 2 is shifted up 2, so turn to your neighbor and tell them your prediction. If there's a minus 3, what do you think is going to happen to the graph? You have to turn back there. Tyson, did you turn and tell someone? If there's a minus 3, what's going to happen to the graph? Predict it. Come on, you're behind. You need to catch up, please. You're also behind, so please do this, not that. Okay, who wants to volunteer your neighbor? Okay, that was the first hand I saw. Jeff, who are you volunteering? Mateo, prediction. What's going to happen to the graph when there's a minus 3? If the plus 2 shifted up 2, what do you think is going to happen with the graph when there's a minus 3? Lower, how many? Ah, there you go. Minus 3 means it's going to shift down 3. Yeah? Let's see if that actually happens. Let's show our work. So So we're going to put parentheses squared minus 3. Because there's an x, we put parentheses wherever we're plugging in. Minus 3. Everyone should be doing this work. If you never practice, you're not going to be prepared for game day, and game day is the test. Okay? If you sign up for a full marathon to run 26.2 miles, and all you do in training is run around the school once, you're not going to be ready to run that 26.2 miles. You're going to be in a lot of pain, a lot of physical pain. Math, same way. This is our practice. Game day is the test. Okay, so please make sure you're following along with us. First, we type in negative 2. Cameron. No, that one's Welch. This one is Keller. Thank you. I have 3 different Camerons this year. Okay, Cameron Keller. What do we get here? Negative 2 squared. Good. And if we subtract 3, that would be 1. Thank you. I'm going to do it again with negative 1. Negative 1 squared. Aria. If we use the exponent, we get minus 3 becomes, thank you. We keep doing this process until we see that vertex, because we'll have a repeat. 0 squared is just 0, minus 3, you're right, is negative 3. Okay, AJ, what about the next one? 1 squared minus 3. What is 1 squared, AJ? Minus 3. Oh, you have a repeat? So this guy right here between the repeat is called your vertex. So go over here and write 0, comma, negative 3. And then we can just use symmetry, so that has to be 1. Pick your other colored pencil. I'm going to choose red. And if you would shade like we did last time, we're going to go up above and we're going to plot these points and see if our prediction going down 3 is correct. Negative 2, 1. Let's see. Negative 2, 1. I can't see them all at the same time. Negative 1, 2, and 0. What? Oh, negative 1, negative 2. That's why I'm confused. Negative 1, negative 2. There, there, there. Did it shift down? Did it shift down 3? Yes, specifically what is shifting? You mentioned the y-intercept vortex. We're going into the vortex like in Star Trek. Scotty, we're going into the vortex. I'm just kidding. I like Star Trek. The vertex. A little different. There's not an O in it. Vertex. Okay, so yes, the vertex shifts down 3. Okay, flip it over. We're going to make a different discovery. We're going to do this with your calculator. Learn how to graph on your calculator. Flip it over. Oh, sorry, I forgot to do one thing on this side. I forgot to do domain, actually 2 things. Domain and range, we didn't talk about that. So my purple graph, that second one that you guys did, that shifted up, what's the domain? How far to the left does this graph go, Maddie? Maddie, along the x-axis, how far left does this graph go? Forever 2. The infinity over there. This to the left would be negative infinity, and the domain here to the right would be positive infinity. So the domain for B, it is the same thing. So are all of the domains going to always be like this for parabolas? Yeah, they're always going to go from negative infinity to positive infinity. So we can throw that one in on C as well. The range changes though, so the range you have to be careful on. Domain will always be negative infinity to positive infinity. Okay, the range, let's do part B. Part B is my purple graph. Fingers in the air. Don't shout it out. Fingers in the air. Which y value is the lowest y value on this graph? Because the range follows the y-axis. Fingers in the air, please. The purple graph right here, how low does it go? And what's that y value of the point? Fingers in the air. I don't see everyone participating. How low does this go? How low can you go? Really low. Isaiah Lang, what's the y value of that lowest vertex point? 2. And how high does it go? To infinity and beyond. So, is there a physical point at 2? Yes. There's a point right there at 2. Elizabeth, what do we put around the 2 if we have a physical point at 2? Elizabeth, what? Thank you. A bracket on the 2, parenthesis on the infinity. There is a difference, so make sure you're very clear. The last one for part C, Alexis, on the range for the one that shifted down, this is part C. How low does this one go? Good, and how high does it go? Great, so on Alexis, since we have a point there at -3, what do we put around the -3? Perfect. So the range is bracket -3 to infinity. One last thing before we flip. Is there any question on domain and range? Okay, we have one last thing to put on the bottom. I'm going to write this many, many times all year. Well, they're using F, so we'll use F for that. F of x equals A times the quantity x minus h squared plus k. 39. This plus k is what we just discovered. If it's after the square, it's outside the function. What type of shifting did we have? Up and down shift. There's a word that starts with a V that represents up and vertical shift. So would you please put VS? Then it happens to be the same sign. If it said +2, we went up because the positive numbers are up. If it said minus, okay, sit with us please. If it said minus, we went down because the negative numbers are down. So I'm going to write the word same to remind me it's the same sign. VS stands for vertical shift. Same. Okay, flip it over to the next page. So it says we have our parent function already graphed. Yes? Yes, please. We have a couple up here. Okay? I'm going to teach you how to graph this on your calculator, so everyone does a calculator. If you open up your calculator, the parent function's already graphed. We're going to have our calculator graph this one so that we can see what happens. We can do it faster. So open up your calculators. Does anyone already know how to graph on a calculator? What button you go to? AJ, what button do you go to? The y equals button. So everyone hit the y equals button, which is in the top left. Clear out the stuff in there. The x squared, if you already have that, you're good. But if you don't have x squared, because like you have your own calculator and you haven't typed that in yet, where is the x button? Where is Chris? Oh, it's not Chris. Isaiah. The other Isaiah, Cooper. That's going to be our square button. Right by the green alpha button, right? To the right of the green alpha button. Push that as your x, and the squared is diagonally up from the 7. Diagonally up from the 7. That's your parent function, x squared. Use your calculator open, please, and type it in. Okay, now we're going to put in a second function, this one right here. In parentheses, x plus 2 squared. So, arrow down, so you're on y2. Put parentheses. Now there's plenty more. This one works. Go to y equals, please. Parentheses, x plus 2, close the parentheses, squared. Remember, the square is diagonally out from the 7. The x is right next to the green alpha button. Okay, to make sure everyone's calculator is graphing in the same window as mine, you go to Zoom. Go to Zoom and tell me, what does number 6 say? Standard. So if we want everyone to be in the same standard window, that's going to just put the window -10 to +10, -10 to +10. Push number 6 and it will graph it for you. Why are there two? Not lines, parabolas. Why are there two? We have two equations. The one in the middle, that is your parent function. But this one over here is the one with the plus 2. This was the y equals x plus 2 squared. Okay, how did this shift, Stetson? How did this one shift? Did it go up this time when we added the plus 2? Stetson? No, where'd it go? To the left, but aren't the positive numbers on the right? It turned to a negative and went left. Interesting. We're going to add another function. Go back to the y equals button, please. And the one on our worksheet for C, I don't remember what it is. Let's see. Oh, the minus 3. We're going to put parentheses x minus 3 squared. So arrow down to y3, then put parentheses x minus 3, close the parenthesis, squared. And then you're ready to go. You don't have to check the window again. It should be the same. Hit graph. Christian, are you doing this? Christian, C? There we go. Oops, I should not have written that way. This one was this one. And the minus 3, does it go left where the negative numbers are? Did this one go left where the negative numbers are? No, which direction did it go? It went right. Gavin? So you have to make sure on y equals, make sure all the equal signs that you want graphed are highlighted. So, oh, your calculator is one of them ones I don't know how to fix that other than reprogramming it. Where's just one sec. Let's see. Okay, you'll have to go back in and type them in, but it should work now. Okay, so when it says plus 2 in the parentheses, it goes left. When it says minus 3 in the parentheses, it goes right. So on our little detail down here, if we rewrote this, at C, rewrite f of x equals a times x minus h squared plus k. The k we did on the first page, and I had you write, we're writing this a second time, on the bottom of the page on part C, the k I had you write vertical shift same. This time, we have something in the parentheses, just like this h is in the parentheses. It was not a vertical shift anymore. What type of shift does it become? Cheyenne, what type of shift does it become? Did they go up and down, or did they go? They did not go up and down. Here's the original, and they all, oops, different color. Here's the original in blue, and the red and green ones did not go up and down. They what? Which means right and left, right? So that's a horizontal shift. But when it said plus, it went left. When it said minus, it went right. So we wouldn't say the word same for this one. It would be another word. Different? Okay. If it says plus, you would think it would go right because the positive numbers are to the right, but it went left. Can you think of a word that starts with an O that does the, that's the one I want. Opposite. So, when I see this function, Skylar, I say opposite, same in my head, because that's your vertex, always. Opposite, same. Opposite, same. Okay? So, we can go get some points using opposite, same. I just told you your vertex. See this guy right here? Plus 2 is inside the parentheses, outside the parentheses is actually plus 0. So what's the opposite of this number inside the parentheses? It says plus 2. What's the opposite? Minus 2. Same this number. 0. That is your vertex. So on your chart, there you go. Can you sit up, please? On your chart, negative 2, comma 0. Turn around, please. Okay, negative 2, comma 0. that is your vertex. And if we just go through really quick and get the point so we can graph it, we don't have to get the point of the vertex because we already know it. In parentheses, -4 plus 2 squared. This is part A. -4 plus 2 squared. You have to do parentheses this time first. Dylan, inside the parentheses, what would we get if we added those? Good. And then Dylan, if we square the -2, we get what? Good, because a negative times a negative is a positive. Okay? I'm always going to remember you as Jessica's sister now. Hold on. Pause. Elena. For the next one, we plug in -3. If you can do the math for me, Elena, inside the parentheses, what's -3 plus the 2? Good, and if we square the -1, right, so we have +1. And then we already know the vertex, so we can use symmetry. The next guy's y value would be fingers in the air. What's it going to be? Without even doing the work, if you know symmetry, fingers in the air really quick, what's this going to be? If this guy's your vertex, then they should be good. 1, repeating, so this is going to be 4. Pick one of your colored pencils, please. Highlight, color code that, and then we're going to graph it on the graph up top. -4, 4. That means we go left 4, up 4. -3, 1. Left 3, up 1. -2, 0. Left, -2, stay at 0. And you just use symmetry for the next guys. Make sure those points are large enough that when you graph through them, they don't disappear. See, it has the exact same shape as the other function. I already graphed it, except for it is shifted to the left. That's how you do your homework, yeah. The domain, does it always spread left and right to -infinity, positive infinity? Alex, does this graph go to -infinity and positive infinity when we go left and right? Yes. Domain is always going to be the same. It's the range you have to be careful on. So for part A, domain, put d sub x. We never reach infinity, so we're going to have -infinity with a parenthesis, comma, positive infinity. The range will be the one you have to be careful on. The range, put r sub y. Okay, look at the green graph. Fingers in the air. What's the lowest point? The lowest y value. Fingers in the air, please. What's the lowest y value that this graph is going to hit? Because range is the y values. What's the lowest y value? I don't see everyone's fingers in the air. Follow that graph. When you hit this point, what is its y value? Fingers in the air. Okay, is it -2 or is it 0? I see both answers coming out. The -2 is the x value, but 0 is the height, right? Because y is the height. So we put bracket because we have a point there, 0, comma, infinity. Yep. Really quick for this one, we already know the vertex was opposite same, 3, 0, we did it on our calculator. Domain is always -infinity to positive infinity. It's the range that changes. So I'll just give you the table for time because we don't have much time left. 2 minus 3 is -1 squared. That would be 1. 1 minus 3, -2 squared is 4. Oh, that's interesting. Does it have the same y values as the last table? Yes, therefore the range is exactly the same. Okay, and lastly, before we clean up, go plot that, color code it with your colored pencils, and it's the same points except for it's shifted over to the 3. And then draw your parabola through. Make sure your parabola goes all the way to the top.